Hey everyone, welcome. So in this series, we are going to explore the OWASP top 10, the most important web application security risk you need to know, whether you are a developer or a student, an application security engineer or security pros. You need to know the basic, or you need to have the basic understanding of this OWASP top 10, right? So in this video, to make it easier to understand, we will use an airline system, just an imaginary airline system, as our running application or as our running example. So that way each vulnerability connects to something real, right? For example, like passengers data, booking systems, or flight operations. And yeah, so in this video we'll be covering the first five of them, and the next video will be covering the next five, the rest, right? So let's get started. So the first one is broken access control. So what is broken access control? How does it happen? Well, it happens when a system fails to like properly enforce permissions over resources, right? So in simple terms, a user can access data or perform actions that they shouldn't be allowed to, right? So just for example, here imagine you're logged in into an airline booking portal, and your ticket URL ends with like booking slash like the booking ID right here, right? So if you change it to like something like booking slash another booking ID here, and suddenly sees another passenger's booking, that's what we call broken access control, right? So here the user didn't actually hack the system or bypass the authentication. They were already logged in. So the problem is the system simply failed to verify whether they were authorized to access that specific resource, right? So just to make this more vivid, here I prepared a drawing. Is very simple. A drawing here. Let's say this is our booking site, right? So there are two people here who wants to like book a seat or whatever they want to do. So here Abel and Sarah, right? So when Abel books a seat, the system, let's say, returns through this URL or through this API, it returns his or her in our case, Abel's information here, right? For example, the booking ID, the name, and the other PII data, right? The same is true for Sarah, right? Her PII data is also returned through this API. So the question is, here, logged in as Abel, can we actually access Sarah's booking detail? So how can we check that? So here it says /123. So 123, uh, uh, it uniquely identifies the booking for Avid, right? But what if we change it to some other number to see other people's data, right? For example, let's say 321. Can we actually access Sarah's booking detail? That's the question. If that is true, well, that's BOLA, right? Broken Object Label Authorization. So moving to the next one, cryptographic failure. So uh, so cryptographic failure, it actually happens when data isn't properly protected, right? It's like locking your suitcase, for example, with a weak zipper. And attackers can easily open it, right? And we must use actually a strong encryption so that stolen data becomes useless, right? So let's imagine, for example, here our airline industry keeps his or his their customer loyalty database on the cloud or something like that, and there they store their account number, the customer data, your the password, including the password, right? So what if let's say what if a data breach happens, right, on this database right here? on the customer loyalty database right here. So the attacker immediately sees the password and the username and everything plain text, right? So this is just instead of like securely hashed password, right? So this is what we call a cryptographic failure. There, the idea behind cryptographic failure is very broad. Another example can be, for example, let's say a passenger connect to an airline Wi-Fi and log into their airline and mobile application, right? And let's say the app sends the login information over HTTP instead of HTTPS, right? I hope you distinguish the difference between HTTP and HTTPS. So if the login information is sent over HTTP, well, anyone can actually have anyone on that same network, right, can potentially intercept the traffic using, for example, Wireshark or other sniffing tools, right? So the key message here is like encryption is not about hiding information, right? It's about making a stolen information useless, right? So that's the key idea behind cryptographic failure. So the other one is injection. So injection, it is when a hacker trick a system into running their code. As simple as that, right? So imagine someone sneaking a command into a form box, right? For example, in the login page, which I will be showing you in a second. Suddenly, the database obeys them and um, and execute that command, right? So always we have to separate user input from system commands, right? So let's see an example right here. So injection, let's say the portal or the admin portal of the airline has got this uh, a login page which accepts this email and password and just simple, right? So on the back end, it has a query that is going to be executed by the backend uh, backend service, which goes like select all from users where email is equals to email and the password is equals to password. So far, so good, right? So what if we insert this specific command in the password field? What will happen? Why? I mean, how does the query react to that, right? So it will become something like this. So select all from users where email is equal to Mycora. So let's imagine Mycora is a valid username, right? So where email is equal to Mycora and password is equals to null, which might be false here, but or here it says 1 is equals to 1, right? So here this is true, 1 is equals to 1, and this might be false, but false or true is actually true, right? And true is true, so the attacker can bypass um, uh, the authentication flow of that specific system, right? There are a lot of injection examples, just the basic one. I just want you to understand the basic or the definition behind it. So let's move to the next one, which is insecure design. So insecure design means the system was built without thinking about safety from the start, right? It's like building a house without doors that lock, right? Security should be the part of the design. It's not an added later, right? Something that we need to incorporate during the first phase of our SDLC or software development lifecycle, right? So let's uh, let's uh, let's see some example, right? So the airline, for example, might allow, let's say the airline allows passengers to reset their account using only their frequent flyer number, for example, or their date of birth, right? Which both public, which are both publicly guessable, right? Enabling full account takeover. So whoever knows my, for example, date of birth can reset my password, This is an insecure design, right? Another thing is insecure design flows require architectural work, not just a code fix. We need to revamp all of the flow, right? All of the flow of the process, right? So this cannot be patched, it must be redesigned. So the next one is security misconfiguration. So security misconfiguration, it happens when settings are left open or wrong, right? So it's like leaving the key under the mat and easily, which is easy for attackers to find, right? And always check and harden your configuration. So let's see some real world example. Let's say the attack, the airline is the airline system uses an S3 cloud storage, which is an AWS cloud storage, object storage, and let's all of a sudden we made it to the public, right? Which means it can be accessible to anyone with the URL, right? So an airline, for example, might store passengers' manifests and operational documents inside that cloud storage. And that bucket is, as I said, accidentally configured as public. So here, nobody bypasses the authentication, nobody hacked anything, the data was simply exposed, right? Another example can be an admin portal on the airline system remains accessible at /admin with default credential, for example. And the key message here is many breaches occur because systems were or are configured incorrectly, right? So, so this is all about the first five from the uh, OWASP top 10 list, and I hope you guys got some insight on it. And I'll see you guys in the next video, which I will cover the next five of them. Thank you.